All right, 5.1 book problem number 19 here is asking you to find M5, so we're doing 5 midpoint rectangles for this function right here, f of x is equal to the natural log of x on the interval here from 1 to 3. Now we certainly could graph this function. Y equals natural log of x is one that I'm hoping you guys know and could do without your calculator, but that's really kind of defeating the purpose here. I'd really like to get used to doing these without the calculator. The one thing you're going to need to know here, guys, we were already given right here that our number of rectangles is going to equal 5. The tricky thing about this problem, though, is that we don't know what delta x is, and it's kind of some weird numbers. So let's use this formula that we wrote down in our notes for 5.1. Delta x can always be found by taking the difference, b minus a, which are the width of the whole interval, and dividing that by n. So in this problem, our b value, the right endpoint, is 3. The left endpoint, a, is 1, and we're dividing that by 5 rectangles. So we get this weird value right here of 2/5, or if you would prefer, 0.4, and that's delta x, which is the width of each rectangle. Now, as I'm hoping you guys know by now, anytime they ask you for this type of setup right here with a function that's explicitly defined, we're going to be doing regular subintervals. So to work on this here, guys, we're going to say M5 is equal to, we're going to be taking the area of 5 rectangles and adding them all together. And in a problem like this with regular subintervals, all those rectangles are going to have the same width, and that's going to be this delta x value right here. So I'm going to bring that 0.4 out in front, and then for each one of these rectangles now, we're going to evaluate the height at a particular spot. So the height of the first rectangle is going to be f of, and we're now going to need to evaluate it at the midpoint of its first subinterval. Now, I just got done saying I don't want you guys graphing here, and that I think that's still good advice. But it's not a terrible idea, just if you guys drew a number line right here and said, okay, what's going on? We're starting this region right here at 1. That's our A value right here. We're ending the region right here at 3. That's our B value. And we are going to partition this interval into 5 subintervals. So I don't think I'm going to do a very accurate job, but frankly, I don't care that much. I'm going to try to draw 4 little lines in here and thereby creating 5 subintervals. 1, 2, number them if you want to, 3, 4, and 5. And I would do that on kind of a tricky problem like this because I think it's going to be difficult to see or just to kind of conceptualize where these subintervals are going to end. The first subinterval right here starts at an x value of 1, and then it jumps 2/5 or 4/10 of a unit to the right. So I'm going to go to 1.4 here and then just keep adding 0.4. So the second subinterval ends at 1.8, the third at 2.2, the fourth at 2.6, and sure enough, 2.6 plus 0.4 gets me to 3 right there. Now, why is that important? Because now, everybody, we're going to evaluate the height of the first rectangle at the midpoint of this subinterval right here. So since this first subinterval starts at 1 and ends at 1.4, f of 1.2 is going to give us the height of the first rectangle. And then from there, guys, we're going to add f of, we're looking at the midpoint of subinterval number 2 here, which is going to be 1.6. And of course, I do want to point out, what's the jump between the first x value, that midpoint, and the second midpoint? It's equal to that delta x value, just like it always is. Now, I'm going to skip the heights of rectangles 3 and 4 and then jump to the very end. The last subinterval has a midpoint right here between 2.6 and 3, so that'll be 2.8. F of 2.8, therefore, gives us the height of that fifth rectangle. Now, with 5 rectangles, it isn't all that bad to go ahead and just put that into the calculator right now, but I want you guys practicing your sigmas right here. So I'm going to lead off with my delta x, my 0.4, and then put a nice big sigma out in front and get working right here. We're going to begin at k equals, and I would ask you guys, if we were in class right now, how you want to begin. This one, I'm going to start at k equals 1. I think 1 and 0 are the 2 smart ways to begin. If we're starting at 1 and we want 5 rectangles, we're just going to end this thing at 5. If we had started at 0, we would have ended this at 4. You have a choice on which number to start at on the bottom, but then you don't have a choice for what number to put on top. And then what comes next here, everybody? For the height of each rectangle now, we're going to multiply that. Let's see here. So it's going to be f of, and we need to come up with a linear expression with a slope and a y-intercept that starts at 1.2 when k is equal to 1 and eventually ends up at 2.8. So the first thing we need to know, what is the slope of this function, or better yet, the jump in each one of these x values? Again, that's what delta x is for. So this is going to be a 0.4 multiplied by the variable k. And let's think real quick of where we are. We start with k equals 1. So 0.4 times 1 is 0.4. And what do we need to do to 0.4 to get it to become 1.2? We need to add a 0.8 at the end of all that. I would check your second value right here, which is what we do when k equals 2. 2 times 0.4 is 0.8 plus another 0.8. That gets us 1.6. Good. And I always like to check the last one, which should work when k is equal to this value here, which is 5. 0.4 times 5 is going to get you 2, and 2 plus 0.8 is 2.8. So I feel pretty good about this expression right here. Now, I'm going to do this with you here, guys. I'm going to jump over to my calculator. I'm going to ignore the Algebra 2 work that I was just doing. And the first thing we're going to need to do is define this function, everybody, which, if I recall, was f of x, gotcha, was equal to, and this was just the natural log of x, gotcha. So what do we have here, guys? If I remember this right, we wrote down our delta x, which was a 0.4, and we're multiplying that by a summation. So you guys are going to hit menu. Let's see. For you, you're going to hit the calculus button, which I think is number 4, and then the sum option, which on your calculator, I think that's menu 4-5. And what are we doing here, guys? I put a k in there. I don't have a k on this screen. Does it really matter? I'll put an r. Sure, we'll go with that. I'll probably screw that up in a minute. And I started at 1, okay, and then let's see, from there, we went from 1 to 5. And then this expression here was a 0.5. You guys did a k, but I'm going to do an r. And then it was a plus, wait a minute, I lied. It was 0.4 times r. And then I think it was plus a 0.8. But I'm going to go back and double check that. Whoop, whoop, whoop. Okay, let's take a look. So we're going from 1 to 5, 0.4k or 0.44r plus 8 with an f in front of that. So I think I typed that in. No, I did not. I forgot to put the f in there. That's the whole point of defining all that. So here there should have been, and let's get this right now, f of parenthesis, and then all that. Okay, and I think that's going to get us our answer there, guys, of 1.300. Now remember, we always write to 3 decimal places right there, even if that's not quite, you don't think that it's necessary. We do need to show that accuracy. I'm going to assume that that's right. I'll check that answer, and if it's wrong, I'll come back and fix it. But otherwise, there's our answer for 5.1, number 19.